All right, guys, what's up today? We're going to take you through the warm-ups today for January 11th. All right, one thing we talked about in class is how they do these word problems. Like over here, if we see like this one over here that says, the second of two numbers is 6 times the first. Their sum is 77. Notice when they talk about two numbers, they'll say a second one or a first one. They'll say is for equals, and we talked about, can we write these two sentences, y equals 2x minus 3, in word form the way they would have. So for number one, when we're talking about y, usually we can call that anything, but I'll call that the second number. The second number. Now in math, whenever we see equals, we say is. So the second number is. One thing that we notice the way they do also is they'll say, like, I look at the minus 3 and they'll put that already in right after the is, and they'll say is 3 less than, because it's 3 less than something, so you can put that at the end, and that means minus 3, and that's where the minus 3 comes from. And then somehow we have to be able to say this 2x term, which is 3 less than twice, that means 2 times, twice the first number. So usually I call this the y the second number and x the first number. So we could say the second number is 3 less than twice the first number. And then finally, number 2, the way they say x plus y equals 24, we could say the first number plus the second number equals 20 is 24. But usually with these problems, if I go back over here, we'll notice how they say that their sum is 77. So that's a really easy way to say exactly what we just said. So come on, thing, move. There we go. So their sum, which means adding them together. So over here, we're just going to say their sum is 24. All right, so those would be the two sentences that would take to get me the problems for number 1 and number 2. Number 3 says, can you use substitution to solve 1 and 2? So if I was doing number 3, I'd have to write 2x minus 3 equals y. I wrote it backwards, but same thing. And then also x plus y equals 24. I know that y is exactly the same thing as 2x minus 3, so I can take out y and plug in 2x minus 3. And I can write the rest of the equation exactly the same. So if you're at home and you didn't follow along. Now from here, you should be able to figure out what x is equal to by adding them together. We've got x and 2x is 3x minus 3 equals 24. Once I make my teams, I know I have to move the negative 3 over to the other side and make it positive 3. So I have 3x equals 27. I divide by 3. And I get x equals 9. So I know x equals 9. When I go back to the top in my head, I can say, okay, well then if x equals 9, y is 2 times whatever x is minus 3. So 2 times x is 9, minus 3 is 18 minus 3 equals 15. So now I know both of them, y equals 15, x equals 9. Cool. All right, I'm gonna delete those, or I'm gonna erase these. You've got them already. All right, so the next problem is, can we do the substitution when we have 3 letters in it? If we look at number 4, it says use substitution to solve. Here's the problem with this equation. We have an x, we have a y, and we have a z all in one equation. Over here we have a z and an x, so there's 2 letters in that equation, can't solve it. Over here we have a y and an x. You can only solve an equation if it has 1 letter in it. So the first equation has 3 letters, the second equation has 2 letters, and the blue equation has 2 letters also. So we can't solve any of them. But look what happens when basically I know exactly what z is. I know z is the same thing as x plus 5. So over here, I can take z out, and I can plug in x plus 5. So basically now, the black equation doesn't have a letter z. It has x's and y's because I took the z out and I replaced it with an x term, x plus 5. But I can also, I know what y is. I know that y is x minus 2. So I can take the y out also and replace it with an x style term, or x minus 2, because we know they're the same thing. If I copy the rest of that equation exactly, and I gotta find black, okay, 2x minus, we got to bring the 3 down, minus 3 times x minus 2 plus, you got to bring the 4 down, 4 times x plus 5 equals 44. Look at that new equation. The only letter in this equation is x's. So I was able to take the y's out by substituting what I know equals y, and I was able to take the z out by plugging in x plus 5 for z. And now I have an equation that only has x's. So first thing I got to do is multiplication. The 2x comes down, it's fine. But now I have negative 3 times positive x, which is negative 3x. And I have negative 3 times negative 2, which is plus 6. Then over here I have positive 4 times x, which is plus 4x. And I have positive 4 times positive 5, which is plus 20, equals 44. Okay, so I got some combining to do. I can combine the, let's see, the 2x and the minus 3x and the plus 4x. I can combine those to 2 minus 3 is negative 1, plus 4 is 3x. So I combine those, they're all on the same side. I can combine the plus 6 and the plus 20 right now to make plus 26. And then I have equals 44. All right, and keep going. I'm going to move this 26 over to the other side and make it minus 26. And I get 3x equals 18. I divide by 3. And check it out. I was able to solve, with even though that equation with 3 variables, that x equals 6. Okay, so if I know x equals 6, then I know that if I can go up here, y is whatever x is minus 2. So y must be 6 minus 2, which is 4. And if I plug in over here, I know what x is. Then z must be x plus 5. So z equals 6 plus 5, because that's what x is. Z equals 11. So I can solve using substitution as many as I want, as long as I can get an equation that only has one type of letter in there. So that's why I substituted those. I took out the y and plugged in an x. I took out the z and plugged in an x term. And now I turned it from an equation with 3 letters in it to an equation with only 1 letter. As soon as you can do that, you can solve everything. So those are the warm-ups for today.